over-refraction equals to the prescription. You always take the spherical part minus bracket, your contact lens, and also you have to consider your tear lens. For you to know, the tear lens is always added to the contact lens. So for you to get your tear lens, you have to minus the flatter meridian from the base curve. So if the base curve is not given in diopters, you have this is Dr. Emmanuel Rich. This video is meant for those that are preparing for optometry licensing exam for Saudi Arabia, and is exclusively for over-refraction. So if you are preparing for this exam, you will know that one of the aspects of optometry when it comes to refraction that you must not neglect is over-refraction. There is 100% chance that you must meet over-refraction question in your exam. If not one, you might meet 2 or 3 or 4 or 5, because there is a way they normally ask questions. If you see one question, it can come out 5 times in the same exam. So, and 5 is a big percentage. So over-refraction, I want to explain it in a simple term, the way you will understand it and the way it usually appears in the exam, and the way, if you understand the concept, the background of over-refraction, there is no way you meet the question that you will not be able to answer it. Because one of the things that I noticed from people, usually people that do write the exam, is that after preparing for this exam, when they get to exam hall, if the question is being tweaked in any way, they get completely blackout. They are just off, they don't know where to start again, their memory just closed. So to avoid that, it's always good to understand the background of anything you are reading in preparation of this exam. So most of the people have guided, most of the people have provided any kind of help when preparing this exam. I usually tell them to be thorough in the simple things. Just be thorough on those simple things, on those simple calculations, than those big ones. Okay, because those are the simple ones, are the ones that might make your exam so miserable. So if you know the simple things like converting plus seal to minus seal, you should know it in any way. Just know the simple, the fundamentals of that, so that in any way they bring the questions, no matter how the story they tell, after saying a lot of things, and they still give you what you need to see, you will be able to answer the question. Because one of the things that do confuse people is that when they give in the question in the exam, sometimes they will give you a background knowledge. At the end of the whole thing, they will ask the question. So most people, after reading the whole background of the questions, they will get confused without knowing how to pick out what they need, the simple things they need. So when I was preparing, I learned to focus on the simple things. If you have a solid ground on those simple things, you'll be able to tackle it. No matter how complex the question comes out to be, you'll be able to tackle it. So in this video, without much wasting time, I want to talk on over-refraction. So over-refraction is one of the questions that you must see in your exam. There is no two ways about it. It's part of refraction. And you know that refraction has almost close to 20% to 21%. Sometimes it can get up to 25% of the total questions you will see there. So out of the 100 questions, and out of 8 areas of optometry. So you should know that refraction is a big part of the exam. Without wasting much time, what's over-refraction? The simplest form will help you to understand the complex form of this question or of over-refraction in any way it appears. So let's go again. Over-refraction is just a refraction over a contact lens in the eye. So there is a contact lens in the eye already. Then you now perform over refraction on that contact lens. So why is this done? Sometimes it is being done to refine the power of the contact lens after prescription. Okay, so how does it work? Let's say a patient, when you did your refraction, your normal refraction, a patient has let's use simple form, that's a sphere. A patient got minus 2.00 diopter sphere prescription. Okay, so you now give the patient this power to wear as a contact lens. So when the patient put on this power, now you did another refraction while the patient is wearing this power on his or her eye. So when you did a refraction, so with this power the patient got 6.6, good. Now when you put on the contact lens and you did, when the patient put on the contact lens and you mount a trial frame on the patient's eye, and you now started refracting the patient again over this contact lens on the patient's eye. So let's say when you started, you added minus 0.050, and the patient says the vision is not clear, and you notice that the vision is not clear. So you remove the 050, then you put plus 050, and the patient was able to see a more distinct vision or clarity. So when the patient says that he prefers this 050 over the trial frame, so that means that and the patient is using minus 2.00 ds as contact lens on the eye. So but when you add this plus 050, the patient was now seeing better. When you remove 050 and the only power on the patient's eye is this minus 02 minus 2.00 ds contact lens, then the vision was not that clear, was not that distinct, and you've checked all the parameters, everything you need to check. The contact lens is well fit, it's not tight, it's not loose, but you notice that when you add this plus 050 over the trial frame, the patient sees better. So what now happens is that you have to refine this prescription so that the patient will be very comfortable on the contact lens. That means that the actual, after this over refraction, you have to tweak this prescription so that the patient will see better. So what will now happen? Your over refraction result is this plus 050. This is the over refraction result. So the refinement you will now do is to add this 050 to this prescription. So how do you do it? Minus 2.00 ds plus 050, okay, which will give you the final prescription of the patient will be minus 150. So this is the final prescription, but this plus 050 is the over refraction prescription. Over refraction, you understand? So this is how it works. So over refraction is that power over the prescription that gives the best VA, which is this. Now your final prescription is when you add the over refraction results to your previous prescription, which is this. So this is the basic concept of over refraction. So let's do it again. Another example: a patient, after you refracted a patient and you got a prescription of let's use plus now, prescription of plus 1.00 diopter sphere, and you gave this patient this contact lens. The patient wore plus 1.00 ds contact lens on the eye. So you wanted to see if there is any form of refinement you need to do. So you mount a trial frame on the patient eye. So you do your refraction, you added plus 050. The patient reported blur, and you added minus 050. In this case, the vision was more distinct than when the patient was just using this plus 1.00 ds. So what will now happen is, if this gives the patient the best and most comfortable visual acuity, then you have to refine your prescription. So this is the over-refraction result, but your final prescription is now this plus 1.00 ds plus minus 050. So your final results will now be plus 050 ds contact lens. So this is your this is your final prescription, but your over refraction is minus 050. I hope you're understanding it. Before we go to the complex question you are seeing on the board, on the video, because we will attempt that the question you are seeing there, so that you understand the more complex form and the way it appears in the exam. So you might see it in this simplest form, and you can also see it in that complex form, where they will now add both keratometry reading. They will give you prescription with seal, cylinder prescription. They will put a lot of background story, but in this video you will understand how to separate the width from the width. So this is the reason why I'm making this video, for us to understand the basics. When you know these basics and you understand everything, how it works, you will not get confused no matter how the question comes. Let's attempt the question on the screen. In this question, they gave us refraction results, they gave us keratometry reading, they gave us the contact lens power that was in the eye, and they gave us the base curve in millimeters, that was 7.75 millimeters. So and they now ask for expected over refraction. In my explanatory video from the beginning, when I was talking about the basics, I made mention of the over refraction result, which is the expected over refraction or the final prescription. So when you are dealing with over refraction, you must make sure that they are asking for maybe the expected over refraction, or if they are asking for the final prescription, that's the refined prescription. In the refined prescription, you are now adding the over refraction result back to the prescription. So, but in this case, and when you are talking about this Saudi licensing exam, most of the times they ask for expected over refraction. So let's attempt this question. For you to attempt this question, you know that when you see the prescription, that's the refraction, you will see that this one has seal and a lot of other things, a lot of numbers in the question. So this can immediately get you confused, because you might not know what to do with the 180 axis and the 180 meridians there. You don't know what to do with the seal, you don't know what to do with the contact lens, and you don't know what to do with the base curve. So this is how you go about it. So the formula that I derived when I was studying was this, and this can help you so much in your exam. So for us to do this, the formula for over refraction is over refraction is equals to you can say spectacle lens prescription, or the subjective refraction, or the refraction result, minus, in brackets, contact lens, that's the contact lens on the eye, plus the tear lens. Okay, so we have three things here. One is the refraction result, two is the contact lens, and the three is the tear lens. So how do we get all these things? Now in this in this question, they've given us the refraction result, which is the minus 3.00 minus 250 axis 180. This is the refraction results they gave to us. Then the contact lens on the eye is the CL on the eye. That's the trial contact lens they are using, and is an RGP contact lens. I will tell you why they usually give this rigid contact lens, because of there is something that is the reason why they give the RGP. They will always mention that is an RGP most of the times, so that you will know what to do with this cylinder here. So the rigid contact lens they gave to us is minus 4 diopters. Then one thing is missing here, which is the tear length in our formula. So but for us to understand tear length, the tear length formula is the flattest, that's the flatter K reading, minus flatter K minus the base curve. So, and we can see that in this question they gave us the base curve, but we have to convert this base curve to diopters so that we'll be able to minus it with the flatter K reading. And our flatter K reading, so we will now say that our tear length here is, which K reading is our flatter K reading, that's 43.50 at 180. This is our flatter K reading. So you have to minus it with the base curve. So the next thing we have to do is to get our base curve in diopters so that we'll be able to minus and get our tear length. So how do we do this? Okay, so the formula for the base curve, if you want to convert it to diopter, you know this constant 337.5 over the base curve they gave you in millimeters, so that you'll be able to convert it to diopters. So if we do this, our base curve here will be 337.5 divided by 7.75. So when we do this, it will give us, you can use your calculator to do it. In the exam they will provide a calculator for you, so you'll be getting 43.50 diopters approximately. So this is what it will give you. So for us to now get our tear length, so our tear length will now be the flatter meridian, which is 43.50, minus this 43.50, which is our base curve. So our tear length in this case is 0. Okay, hope we are following. Our tear length is 0. So let's go back to our formula. So our formula is over-refraction is equals to our refraction results with our spectacle lens prescription, or the refraction results minus our contact lens minus plus our tear length in brackets. So we've gotten everything. So what are we going to do now? We want to see how we can remove this seal here, but the tear length has already shown us, our base curve has already shown us that it's aligned with the flatter meridian. Our base curve, which is 43.50, is aligning with our is the same with our flatter meridian. So our base curve is 43.50 and the flatter meridian is 43.50. So, and it gives us this 0 tear, so there won't be any tear length power in this prescription. And this is a rigid contact lens. So one of the properties of a rigid contact lens is that it takes care of corneal astigmatism to up to even 3.00 diopters. So once your corneal astigmatism is below 3.00 and the lens on the eye is an RGP, and listening carefully, the power is less than 3.00. The contact lens is an RGP, is a rigid contact lens. So let's make it clearer so that you understand. Now, I was trying to explain about how to get your tear lens and why the cylinder under prescription, how it was taken care of. Okay, so this is the formula for tear lens. So, and I also gave the formula for base curve. So tear lens is flat K minus BC. So, and I also said that BC is equals to, this constant 337 over the BC. So you use this formula to switch BC into that base curve to diopters. So to diopters. So this is how you can get your tear lens. So we did that, and we discovered that our flatter meridian and our base curve gave us the same value, which is 43.50, and when we subtracted it, our tear lens was 0, showing that this lens, that's this -4 diopter contact lens on the eye, is resting on the flatter curve, and in such case there won't be any form of tear lens formation. So that, and I was now explaining to you how rigid contact lens is normal, and this is the norm, that rigid contact lens takes care of corneal toricity that is below 3.00. Okay, so, and secondly, for us to neglect or take care of that -250 seal on the prescription aspect, we need to consider these three things. One, the type of contact lens. Is it a rigid contact lens? So if it's a rigid contact lens, we are good to go. The second thing you should look at is the flatter K equals to the base curve. So if the flatter K is equals to the base curve, there is nothing to worry about. But if the flatter K is not equals to the base curve, that means you have to add the difference to the contact lens prescription. Okay, the third thing is to look at the astigmatism to know if the astigmatism, that's the seal aspect of the prescription they give to you, or the refraction they give to you, if it's less than -33 diopters. So most of the times they will give your cylindrical prescription that is less than this. So, and once your lens is a rigid lens, so you don't have anything to worry about the cylindrical aspect of this prescription. So let's continue. So we have gotten everything we need. So let's go back to our formula, which is over-refraction is equals to our refraction results minus, into brackets, cylindrical prescription plus the tear lens. So let's put our values. This is equals to, our prescription is now -3. So we are taking the spherical aspect of that prescription. Since this is a rigid contact lens, it has the tear lens formation there is 0. So, and it's just at the flatter K. So once the rigid contact lens, once it's a rigid contact lens and the cylindrical aspect of the prescription is less than -3.00, you don't have anything to do with the cylindrical aspect. Just take the spherical aspect of the prescription. So the spherical aspect of this prescription here is -3, then -3 minus, into brackets, the power of our rigid contact lens is -4, and our tear lens from our calculation is 0. So we have to open the bracket, which is equals to -3.00 minus, open the bracket, minus, that minus times minus will give us plus 4.00. So although we have to add this first, so but since this is 0, so it's already 4 there. So this is what we have. Then the final expected over refraction is minus 3 plus 4, which is plus 1.00 ds. So this is the answer of the question we have. The option, you look for this plus 1 diopter sphere. This is the answer. So to cross-check this answer, let me also explain how you should know that this is the answer. This is the expected over refraction. Now cross-check this. Let's do something. So our prescription is this: minus 3.00 minus 250 as this 180. Let's put this prescription in an optical cross. I want us to cross-check to explain to you from the basics I was trying to explain at the beginning. So when we put this prescription in an optical cross, this minus 3 is at 180 as 180, then minus 5.50 in our 190. So we said that the over-refraction is plus 1. And okay, what happens here is the patient puts on a contact lens of minus 4.00. So, and the patient, you know that this is a DS, this is a spherical rigid contact lens. Now, let's say this is the prescription you gave the patient. So when the patient wore this minus 4 on the eye, let's draw our optical cross again and put on this minus 4. So it shows that here will be minus 4.00, and this place from our 180 meridian to this is always 150, is always 250 difference. So so this will be 650. So if the patient is wearing this minus 4 as a contact lens, this is what the prescription will change into, to minus 4.00, which is at 180, to minus 6.50 at 90. Why is this so? It's because the constant difference between the flatter and the steeper meridian is minus 250 still, which you are seeing on the prescription, final prescription. So when you give a patient minus 4, automatically you over minus the eye by 1. So for you to correct that over minus on the eye, you need a prescription of plus 1.00. So when you add 1.00 to all these prescriptions, you will go back to having your minus 3.00 and minus 5.50, which will also give us our initial prescription they gave to us, 250 as this 180. So this is how you do your over-refraction. So expected over-refraction, that has to do with your K reading, your contact lens prescription, and your refraction prescription. The formula is over-refraction equals to the prescription. You always take the spherical part minus bracket, your contact lens, and also you have to consider your tear lens. For you to know, the tear lens is always added to the contact lens. So for you to get your tear lens, you have to minus the flatter meridian from the base curve. So if the base curve is not given in diopters, you have to convert the base curve in diopters by using this constant 0.5 over the base curve they give to you in millimeter, then you get it in diopters. So I hope this helps you to understand. But if you are still confused in any aspects of these, you feel free to type your question on the comment section, I hope I will see it, and I will also explain further in a simple term how you can organize this idea and use it to solve any form of complex or simple over refraction questions. Thank you.